Welcome back, this is Professor Xiaoma. In this video, I will demonstrate and explain a specific hands-on problem. Now keep in mind that in demonstrating the hands-on problem, I will use an example dataset which is default 1. When you do the homework, the dataset is different, so make sure that you adapt the code to work with the homework. In the video, I assume that whatever Python package that we will be using, you have already installed them. If you realize that you haven't installed a specific package and you need to install it in the middle of the video, simply pause the video and go ahead and install it. Install the Python package by following the tutorials that I uploaded. Now let's get started. For this demo, I'm still using the default 1 dataset as is used in many of the other homework videos. Implementing a logistic regression model with regularization is actually very similar to the implementation of logistic regression without regularization. And the difference is highlighted here on this timeline with notes, cheat sheet, with the differences circled in red and indicated as red. As you can see here, all else are the same with logistic regression. The differences are in two places. One is in calculating gradient descent. So the gradient function has an additional term. Another difference is in calculating the cost value. It also has another term. The gradient function has another term, which is lambda. Lambda is the regularization coefficient timed by those elements of the weight vector that is associated with the input variable. So beginning with index 1. So that is the only difference in the gradient function. In terms of the cost function, the additional term is the L2 regularization term. That's how it's defined. It is the squared term of all the vectors and the sum of the squared term multiplied by half of the regularization coefficient. In the implementation level, you would simply add dot function of the same portion of the weight vector multiplied by the coefficient and divided by half. So let's take a look at the implementation. Implementing logistic regression with regularization, all codes are the same, so I will skip to where it's different. This demonstration is built on the data pre-processing steps that are demonstrated in a few other videos, so make sure that you refer and understanding what has been done there. We begin the implementation of regression with regularization. Although the initialization step is almost identical, there are two small differences. One is that I added a new parameter here, a new variable, which is lambda L2 regularization parameter. Lambda is a keyword reserved by Python, so I can't use lambda. That's why I used L2. This is L2 param. Currently, it's taking a value of 1. Another difference is that I directly started with training 2000 epochs. Because with regularization, I do not have too much of a concern in terms of overfitting, and we will see. Let's run this. And these are the same initial values that I got in another demonstration video. Now let's look at the process inside the loop. I will point out the differences from the logistic regression. The first difference is the gradient function. And as you see here, the first part of the gradient function is the same, but the second part is new. It adds multiplication between the lambda L2 regularization parameter with the weight vector beginning with index of 1. Another difference here, the additional term in the cost function, and that is the same as indicated earlier in the cheat sheet. So with this, let's run and train the model for 2000 epochs. Model is run, and let's take a look at the cost values. With 2000 runs, it's already flattened. The learning curve is flattened, and actually it flattened way earlier, about in 150 and 200 epochs. So let's take a look at the model performances. Let's look at the training set performance. These codes are exactly the same as in logistic regression implementation. So with 2000 trainings, the model achieved an accuracy of 0.977 in the training dataset. It's pretty good. It's not perfect. It will never reach 100% just because of the regularization. Now let's look at the performance in the test set. With regularization, the test set performance is close to and almost as good as the training set, 0.965. It's also a pretty good performance score, and the accuracy is similar to the training set. That means overfitting is not likely. And finally, even with overfitting, the performances of logistic regression without regularization is still high enough in the test set. As a final step, let's examine the magnitude of the weight coefficients to see if they are large. Now here I have printed out the biggest 5 and smallest 5 coefficients. As you can see here, the biggest weight here is 7.68, much smaller than the biggest value of the coefficients in logistic regression without regularization. So that means overfitting is much less likely here. Demonstration is completed. Thank you for watching this video. See you next time.